Group 2, the alkaline earth metals. In this presentation, we are going to explore Group 2 elements. Those elements are called the alkaline earth metals, and they are beryllium, magnesium, calcium, strontium, barium, and radon. The three figures show you three of these elements: beryllium, magnesium, and calcium. Unlike the group 1 elements, which are the alkali metals, group 2 elements are not usually stored under oil. Group 1 elements are stored under oil to prevent them from reacting with oxygen in the air. So the question here is, what does the fact that the elements above are not stored in oil suggest to you? That group 2 metals are not used in machinery? That group 2 metals are less reactive than group 1 metals? Or that group 2 metals are more reactive than group 1 metals? Remember that group 1 are alkali metals and group 2 are the alkaline earth metals. Excellent! The fact that elements of group 2 in the periodic table, the alkaline earth metals, are not stored in oil is that because they are less reactive than group 1 metals. So we don't need to be storing them under oil like group 2 metals. This figure here shows you a piece of barium. Barium is also an alkaline earth metal and it's near the bottom of group number 2. Is the piece of barium as shiny as the group 2 metals shown earlier? Well, it's not. If you compare the four figures together, you can see that barium is not as shiny as the other group 2 metals. Remember that barium is near the bottom of group number 2. What does this suggest to you? Group 2 metals get less reactive as we go down the group, or group 2 metals get more reactive as we go down the group? That is correct. There's a trend in group 2, the alkaline earth metals. As we go down the group, the reactivity of the metals increases. So, since barium is at the bottom of the group, this means that barium is more reactive than the elements above. Now let's try adding magnesium and calcium to water in this simulation. So we'll explore the reactions of magnesium and calcium with water. Let's start with magnesium. Magnesium reacts only very slowly with water. It takes actually a few days to collect a test tube of the hydrogen gas given off. And you see this hydrogen gas being given off as bubbles. Now let's try adding calcium to water. The reaction of calcium with water is a strong reaction. Calcium fizzes straight away and hydrogen gas is produced and an alkaline solution is formed. You can see the difference between the two reactions, where a weak reaction of magnesium and water is represented by the slow production of hydrogen gas. However, the strong reaction between calcium and water is represented by the fast and heavy production of hydrogen.